In this example, when we execute the program, the main method is called, which calls method C. So we start from method C, in which at line 4 a string write is created, new string with some content. This string, since it's a new string, it will be created at runtime. So it will be a new string that will be created, and this will evaluate to 10 star 1. Multiplication operator is given priority, so this evaluates to 10. Then minus 10, this evaluates to 0. 0 plus empty string, this gives us string of 0. So line 4, let's say, creates a new string with reference write. So let's say a new string is created here at address 100 0, and this is pointed by write. This is done during runtime. Line 5 is also creating a string middle, and 0 0 string dot substring 0 to 1. So this is the start index, this is the end index. This will be done again at runtime, and then this will eventually come out to be a string of 0, because we're creating a substring of starting index 0, which is here, till index 1. So this is created and this is stored in memory. So again, this would be done at runtime. So a new string would be created with content 0, and this will be pointed by middle. Now line 7 we evaluate string 0 equals to 0. So this is done at runtime, compile time. These all are done at compile time. So let's say 0 address is created. At address 104, a string literal 0 is stored, and this is referenced by 0 variable. Line 7 string left, so string literal 1 is stored at address 105, for example, and left points here, left. So let's say 2 is stored here, and this is pointed by left. This all happens during compile time. And a int equals to 3. So let's say 3 is stored here, and this is pointed by a int. Now at line 12, system out print line. So C0, this is printed as it is, and then 0 equals to 0. So this string literal 0 will be stored at address 100 during compile time. And when we're checking, so this is this equal to is the address same as the string value referenced by the variable 0. So 0 is referenced at address 104. So this would also be 104, and this would also be 104, because both are string literals, right? So they evaluate to be true. So this will evaluate to C0 true. Line 12, C1 would be printed as it is. I'm just gonna write what will be printed here. So 0 equal to left. So is 0 equal to left. Left points at 105, and this will point at 104. Address is different, so this will evaluate to false. This is the address for 0, and this is the address for left. So this will evaluate to false. Is 0 equal to middle? Is the address same as that? So this, since it's a string literal, this will be stored at address 104, because we already have a string literal here. And middle, this will be created at runtime, which will be stored at address 101. So this will evaluate to false as well, because both addresses don't match. Now a int plus a int, so C3 will be printed, and a int plus a int, that gives us 3 plus 3 6. So 6 will be printed. Left plus a int. In line 15, then C4 is printed, and left plus a int. So left is string 1. So this is essentially 1 plus a int plus a int. Again, plus is a left to right operator. So plus 1, this will be evaluated first. So this comes out to be string 1 3 plus 3. This comes out to be 1 3 3 string. So this is essentially what's printed here, 1 3 3. Now that is done, we move on to line 16. C5 is printed, and in this, first innermost brackets are evaluated. So these brackets will be evaluated. Equal to operator operates from right to left. So first right expression will be evaluated. So left plus a int, we just computed that above. This would be 133 string format, right? And this is now assigned to left. So essentially this line makes whatever is stored at left makes it as 133, and then that is added to left. After this bracket is created, whatever is stored at left, that is added to left. Notice that now left is not 1, it's 133, because that is what the value that is stored here at the address in the memory. So 133 plus 133 string both give us 133 133. So this is essentially the output, C5 133, something like this. Now at line 20, C6 is printed, left equals to first the innermost brackets are evaluated. So this is evaluated first. Left is 133 in the memory, right? We can see that from here at address 105. A int is 3. So again this is evaluated first. This becomes 1333, and again 3 is added, so this also is added as string here, and this value is put equal to left, so this value is assigned to left. Now from 133 at address file left points to now a string literal of 1 4 times 3. So this is the value of inner bracket. It is again assigned to left, so this bracket is then evaluated, and in this again this value is assigned to left, and this same value is assigned to left. So left was pointing to value 2 at address 106. Now it's pointing to address 106, but the value is this now because of this operator here at line 20. Now that is done, these brackets are evaluated. So now we add this to left. Just a moment. Now the brackets correct. So now okay, yes, I made a mistake. So these brackets have been evaluated so far, and now this bracket corresponds to this bracket, so this is evaluated, and now we have a statement C6 to be printed inside the print line plus left. What is left? 133, this is left plus then left. So C6 133 is printed. This evaluates to a string C6 1333, and then left is also appended in the end. So left is what? At 105 we can see that left is 133. So this is essentially the output of line 20, something like this. At line 23 you can see that. At line 21 now C7 is printed, left. What is left? 133. So that is printed 13333. This is printed. Line 22 again C7, and then innermost brackets are evaluated. So this evaluates to string 1. So this is essentially string 1 equals to 1. This evaluates to true. So C7 true is printed, something like this. Line 26, C8 is printed as it is. Innermost brackets are evaluated first. So A int equals plus 1. So A int is 3. This becomes 31 string equals to, we can see A int value here, equals to left plus 1. Left is what? Left is string 1333 plus string 1. So this essentially becomes this. Are these at the same addresses? No, neither the content is same nor the addresses are same. So these are not same, and this will evaluate to false. You can assume that this is stored at, let's say, address 108, and this is stored at address, let's say, 109. 13331. These are not the same, so this prints out to be false. Line 28 prints out 1 plus 1. So integer 1, string 1, this prints out string 11. At line 29 we evaluate the innermost brackets first, so this evaluates to 2, and then we add 1. So 1 is added, so string 21 is printed. This is for line 29. So that's the execution of this program.